says two people. Let's try this one more time. Good evening, everyone. Good evening. All right, welcome to the very first Seattle Data Science Meetup of the year. We've had an incredible lap. We've only been around for 6 months and we've grown phenomenally fast thanks to people like you. And we're really excited to kick off our very first meetup with something that has been supported by IBM. IBM has actually taken notice and wanted to see what we're made of, and has been wonderful and brought you all this great content and great food. So we can give one big round of applause for IBM. Yeah, and I really, I wanted to say, I think I've said maybe over and over in the incessant emails that I sent to everyone that thank you so much for all of your support, coming out to our events, proposing ideas, sharing what you'd like this meetup to become, and helping it grow to really, it's one of the fastest growing meetups in town. So without further ado, I'd like to talk a little bit about IBM. We also have another sponsor, and that's Galvanize. All of our meetups have been here at this wonderful space. If you don't know anything about Galvanize, this is first time here at Galvanize. A lot of first timers here, wonderful to see that. Fantastic, fantastic. For those of you who are uninitiated, Galvanize is actually an education company that does a little bit of everything to support new business development. We are a coding school, which provides classes in full stack web development and data science, and soon to be data engineering as well. We are a membership space for freelancers and startups to work alongside other professionals and help them grow. We do events just like this, and we also are a venture capital firm. So if you have any questions about that, please visit us at galvanize.com, or you can come and talk to me. But that's not why you're here. Why you're really here is to come hear about data science. So for our very first talk, we have the wonderful Ruth Stern. Ruth Stern is actually a member here with Galvanize. Very renowned in the field of natural language processing here in the Seattle community, in Galvanize in particular. And she's going to kick off our night with a quick talk about some of the interesting things she does. So please take it away, Ruth Stern.
Hi, my name is Ruth Stern. I have my own little startup called Sternshist, and we're the smallest startup you'll hear about next year that we release our product. So let me get this on. Can you all hear me okay without the mic? Or do you want me to
No, go ahead and put the mic on.
Okay, mic on. Can you hear me now? Yeah. All right. So I have a tiny little startup, and I'm working here at Galvanize, and I love it. And I'd like to talk to you tonight about, I know IBM is sponsoring for that, but I'd like to talk to you about some of the things you can do on Google for a very low cost. A couple months ago, I gave a little talk about getting going on Google with a Jupyter notebook, with your own development stack, and Python free. Google just released in the last couple of weeks a hosted Jupyter notebook that you can get logged in on and get going with BigQuery like that. So I'd like to show you that tonight and show you a few of the examples that Google offers, and then I'll turn it over to IBM and NFL and weather. Okay, so the first thing is you need to go up to the new Google Cloud Datalab. This is Datalab. If you go up here, you'll get this sign on. I'm incognito here because I'm already logged in on my regular tabs. It's connected, integrated, interactive, and familiar. So you have to sign in to start. And you select the cloud project. Here we go. Sternshist. That's marked. And you would click Deploy here. To get going on the Datalab, you do need to be hooked into BigQuery. Well, first of all, how many of you have used the Google platform at all? App Engine? Okay. Should I start there for those of you who are uninitiated? Okay. So, why don't we disclosure, I'm partnered with Google, so they've actually granted me a certain amount of money so I can go out and create all the clusters and all the fun I want, and I basically have unlimited funds. So that's why I'm here. If IBM offers me the same deal, I'm happy to switch any moment. So you would go up to Google Developers Council, that's console developers.google.com, and sign up. And if you go to your home, let's take a look here. You can sign up for a number of different activities. Google is going after Amazon. I believe IBM is also going after Amazon and AWS. And this is a big, big space. Everybody seems to have a little bit of leftover computing power, and they'd love to sell that to us. So in order to use the Google Cloud Datalab, you will need an app engine. You will need BigQuery, which is down here. And I think you can get away with that. And if you sign up for those two products, you can do it. The nice thing about App Engine is it's really easy to get started, and they have a free tier. So unless you're using a lot of data right away, you can have it sitting there and it costs you $0. That's very nice. And so then you go up to here. Once you have those two products set up, relatively easy to do. You go up to here and you click deploy. Does that make sense? You want me to walk through getting going with all those products? If it's UI, if you've used AWS, if you've used anything like that, you can get going relatively quickly. They all have their precious things that you have to figure out, and I will hope that you can do that. All right, so let me get you over to where I am actually logged in. I clicked deploy, and in about 5 minutes I was ready to go. And I just have to find that particular tab somewhere. The nice thing about BigQuery is it has a number of open source data sets. If you go up to Reddit here, they have a list of another freely available data. You don't have to pay the entrance to it. So let's get up to Datalab here. So how many of you are familiar with Jupyter or Python? Have anybody Sage? There's similar things. So Google, this is hosted on Google. It's a little bit special. It's only Python 2.7, but what it does have is you have your own app engine, and you actually have all of the cloud tools available. So you can go through here, and as you can see, I started this 2 weeks ago, and already I'm making quite a mess up here, playing around with different things. It comes with its own folder, Datalab. And in the Datalab folder, it has a number of tutorials, samples, and tools, intros to get you going. So these are the 4 that I've been playing with. You just open it up. So I'm kind of interested in anomaly detection. I think that's a lot of fun. And it gets you going right away. If you move over here, I can clear everything. I can go ahead and clear appeal. These are actually runnable cells. And you can go ahead and run this. I've imported everything. Here's their Google Cloud BigQuery SBQ. And then you can just go ahead and start entering your data sets. This is a public data set for freely available. So does anyone have any questions at this point where you want to get going? Okay. So we move down here. As you can see, you have this wonderful additional thing here with the Google Cloud Series. For those of you at Python, these are called cell magics. And you can just enter SQL and create your own SQL queries right off the bat, right into a cell, and run it. And it will give you the output right here. Go ahead.
Can you please make the text a little bit bigger? Here.
Is it bigger? I guess going, that's what I'm doing. It doesn't seem to be going bigger over and on the projector. I'm sorry, I can't.
Control.
Okay, go ahead. Can somebody tell me when I hit Z because I cannot read?
Down, right there.
Okay. Thank you. Is that clear? All right, thank you. I just do Control Shift Plus and this side is huge. I have one giant over here. Okay, so are there any questions at this point in time? This is very simple. I got up and running in about 10 minutes. And then what I really loved is you can visualize the time series. And now, I'm having trouble seeing where the run rate seems to go. And there is your graph of the time series stats. So this runs all very quickly in this game here. You can get going very quickly. And if you want to enter Python, you can enter Python right here and run it as well. And then it offers a bunch of additional steps that you can take down below. The next, this is one I like. Programming language. Has anyone ever gone up to see the GitHub and looked at the correlations between the languages? You can do that right in the notebook immediately. They start out, and you get the GitHub timeline. That's again a data set. It's freely available for you out there. You don't have to pay for any egress or ingress costs. And it obviously has quite a bit of data in there. And it has over 290 million rows just to play along with. So they get a sample of this, and they're looking at the different languages. And here's a nice example of a query, BigQuery. There are some. This is not full SQL. This is BigQuery SQL. So there are some interesting things to learn, but it's sort of a stripped down version. So if you know SQL, you can go on right here. The joins are a little bit more difficult, but for that you have, 10,000 nodes running to process your queries. Most things come back within about 30 seconds. You would not believe the amount of data you can get through here. You can check out the results, and then what they did here is they did a wonderful little correlation graph, which is just really pretty. Anybody here familiar with pandas as part of data science? Okay, so you've got pandas in here right away. So you can immediately pivot, go and take a look, and then as you get down here, you end up with the correlation here. And of course, in the middle, you end up with JavaScript and Java together. Are there any questions on this? Okay. How am I doing with time? Would you like to see one more notebook? Sure. Go ahead. One more. Okay. So I will give you we can either do genomics or conversion analysis with Google Analytics. Analytics? Genomics, okay. There are a lot of data sets for genomics specifically in Google, and it's a lot of fun. And I don't know if any of you have tried working with this, but all of the private clusters that I've ever done at UW, it's been really slow, and I usually end up crashing them. So it's really great to come up here and be able to query this on the fly and have it come back within 30 seconds. So here you create a big query table, and you have, what I love about this is it shows you how to enter your table names as a variable in the BigQuery SQL syntax. And you just walk right through it, and you can query this. And of course, they only bring back 10. So we'll walk through here's the query, and then they're looking to group them. With this module functionality, it's quite nice so that you can just call it right down below. And here's your TITV ratio. And the run. So I'm not going to run it here. You can actually just take it home and run it. Like I said, 15 minutes to get set up, take it home and run it. And you end up with a wonderful, wonderful visualization right in your notepad. So I put together a notebook with Shakespeare, because I went into computational linguistics, 5 minutes, and I'm off and running, trying to do MLE with Shakespeare. I'm just debugging my code at this point in Python, because I'm a little rusty at it. That's about it. Any questions? Okay.
How do you get your own data in there?
In BigQuery, you can just upload your data. There are also, one of the nice things about IPython is you can, it will allow you to run, let's see if I can, thank you. There's a Control-MN plug yourself. Unfortunately, I don't have to, but if you can do bang, and you have the whole bash shell available to you on the system. You are logged in as root here. I don't know why Google did that, but as long as they've done that, you have full control over the system. If you reboot the system, anything that is outside of here will not be saved. Anything that's outside of this particular directory. The other thing that Google has done, which is just wonderful, is if it has linked you to their own private Git repository. So you can go right over here. You can check in everything that you have here in all of your code immediately. I haven't checked anything in yet because it's all a mess and I'm just playing around with it. If you can check it in here, it's available to you privately. It's only under your Google ID unless you give permission to the project. And you can work with it that way too. So everything that you do here is checked in. If you reboot the machine, all of the additional things outside of this main directory that they've given you to do will get run. That's the one disadvantage of it, but it's a Docker station. So this contents here is all you. Does that make sense? And if you wanted to, you can just pull things up here too and check them in. You also get direct access not only to BigQuery, but you can do it to the Google Data Store or the Data Cloud, the big storage thing. It's like S3 for Amazon. Any other questions? Go ahead.
How much of what you download is stuff that you got versus free stuff?
How much how much did Google give me of what I
Yeah,
demoed?
like, well, what stuff that you download?
Everything that I demoed tonight is free. You will have to give your billing account, and if you start running massive queries through BigQuery, if you start running massive queries through Google Data Store, you'll have to pay the cost, but they'll calculate that out for you.
How do they define query versus, how do they define that capacity?
How do they
How
define
do they
query?
define that capacity? So, like, what's a big query versus a small query?
BigQuery is an actual product, that's what they call it. There's I believe it is based on the amount of data that is moving around the nodes. You can
So
look
it's
it
not
up.
a data process, right?
Pardon?
It's based on the amount of data process.
Yeah, for BigQuery, yes, always. That's all it is. It's just how much data you're moving around.
There's time for one more question.
Okay. All right, now the really good one.
All right, thank you so much.
Thank you.
All All right, as we transition, I'm wondering if the IBM guys are going to drag me to the alley and beat the crap out of me. But you know, we persevere, we do just fine. All right, so next up, I've been told by his company especially that he's the smartest guy they were willing to send, so we're going to have to go with that. But seriously, very exciting, of course topical. Seattle is a city of football and weather and data science, so this talk makes a lot of sense to dovetail all three. So please give it up for Braden Callahan.
Thanks. All right, can you hear me okay? Good deal. All right. So my name's Braden Callahan. I'm a Spark evangelist for IBM, which basically means I go out and try and get people excited about using Spark. So the talk today is really going to be around how I use Spark with a free tool that we have. It's very similar to what you just saw. So it's very fitting, so you can do a little of a pro and con of the two. But we're going to walk through So basically going to walk through some real simple analysis with NFL data. I was probably a little bit over-eager in my topic. I didn't actually get to the point that I could predict wins and losses, but I did find some kind of interesting correlations with some of the different weather data and with like yards and points and those types of things. So I was able to pull a lot of that stuff together. So quick thank you to Galvanize for hosting, all of you guys for showing up. Yeah, there you go. I also really want to thank Sean Foreman. I actually pinged him and asked him if I could use this data set. He is, or I think he owns the ProFootballReference.com, an amazing website for stats. Just really well laid out, it was easy to scrape. So I was able to pull a bunch of his data into Spark and actually use it for myself. So it's really slick, and if you are at all interested in some of the NFL data, I highly, highly recommend it. And then Weather Underground, Wikipedia, I stole some data from them as well. So we can jump into it. So I'm going to go really quickly through kind of IBM and how we view Spark, just 2 or 3 slides on it. So for the most part, right now, IBM is kind of all in on Spark. We're really focused on committing back to giving back to the community and hiring a number of developers that are going to have different projects like the one I'm going to show you tonight, as well as giving back like machine learning libraries, those types of things back into the Spark distribution as a whole. In addition to that, we're also taking the Spark code and incorporating it to a number of our existing products, so make them better. So if you think of things like SPSS and our big data platforms and all those different portfolios, we fully intend to take advantage of Spark in all those different aspects that we can. So like right now, I think we have about 3,500 developers within IBM that are using Spark in some fashion for product development internally. And then, like I said, about 350 we're planning to hire to actually give back to the community. Most of those people will be based in the Spark Technology Center that's in San Francisco. And the other thing is to foster the community. So IBM's commitment is to educate as many people as we can around Spark, around big data in general. And we have a number of ways of doing that. Part of it's like me speaking tonight. Other ways are the Big Data University, which is a great resource for anybody to go out and kind of learn different technologies. We partner with a bunch of people. So it's not just IBM-driven content. For example, there's classes out there on how to learn Scala. There's classes to learn different technologies above and beyond just kind of core IBM stuff. So this is BigDataUniversity.com. This is where the classes are. The group that's actually responsible for Big Data University is also the group that has created the data science workbench, which I'm going to walk through tonight with the analysis that I did. So it's a great free tool to go out and use and kind of have as a test bed to learn a lot of these different technologies and the approaches that stuff that we're talking about. There's the data scientist workbench as one resource to go out and run Spark for free. In addition to that, we have Plumix, which is our platform as a service. Within that, we have what we call Spark as a service. And that's actually a pretty clever way to go out and take advantage as well, and it can scale. So it's a really good way to kind of get started with Spark, learn the technology, and then if you need to scale up or out, you certainly have the capability to do that beyond just the free tier that exists within. And then of course, we have Spark within our Apache distribution, or Meetup distribution as well. Okay, so can we correlate winning and losing to specific conditions? Or can we look at weather, and we take weather and bump it up against different teams or different aspects of these teams? Can we figure out, is it impactful? So that's kind of the whole talk tonight. Blatant honesty, I didn't find anything super profound. It's kind of common sense stuff, but the data certainly backs it up. And it's kind of a fun way to go in and look at how these tools are, how Spark works. So the data sources that I'm going to go through, I pulled a ton of the source data, like I said a second ago, from the Pro Football Reference, Weather Underground. I used the Weather Underground API. We just acquired Weather Underground, and so we actually provide their APIs now as a service that you guys can take advantage of. And this will go through a good example of what that would look like, or what those data sets will actually look like. And then Wikipedia, when all is lost, I needed to kind of fill in some stopgap, and I was able to scrape Wikipedia and fill some stuff. So on the pro football side, tons of information, great site, super easy to navigate, super well laid out. It does look like it was built in the 1990s, but that's because it's just a bunch of hyperlinks, and it makes it really, really easy to navigate with Python. Some of the challenges I had were, I had all this great data, and I knew where or who the home team was, but I had no idea what state, I knew which stadium it was played in, all these games were played in, but I didn't know what city it actually was in, hence having to go to Wikipedia and look up which city they existed from. But it was a good exercise in kind of marrying it, or at least I hope it will be as I walk you guys through it. And then I had some normalization problems. So this is what the actual data sets look like, at least on their web page. And what we have is a column with the winner, a column with the loser, and then all of the stats for the winner and loser that exist across all of the columns. So it's a little bit challenging, and I have to pivot that data. So I'll show a simple way to do that. So that was a bit of a challenge. And what I don't show here, you can do on your own, is if you click on box score, that actually takes you down to the stadium information that I pulled. Or no, I do have it. It's right there. So it shows the box score, which just simply shows me the stadium that I need to actually get to look up. And I probably could have drilled into it and got the city, but I didn't. So here's the Wikipedia page I pulled. This has each of the stadiums and which city it exists in. Pretty simple. A little bit better picture of that. And there's my Weather Underground data. I'm sure that makes a lot of sense to everybody, especially in the back. So basically, Weather Underground is going to give you a nice JSON blob back for historical data. What I did with that is I just pulled the day's summary. I could have gotten really fancy and tried to pull time and all that stuff, but I didn't. I just pulled summary. That's just a quick diagram to kind of show the path that I had to go down from the pro football data, from the box score to Wikipedia to get to the city-state to actually be able to pull the weather and the history of that weather. Okay, so enough of PowerPoint stuff. As fun as that is. Let's flip over here. Okay, so this tool, this is the data science workbench. Again, it's very similar to what you guys just saw. It's a Jupyter-based notebook that allows you to run Scala, Python, and R. So you can see somewhere in here. On the top right here, we have the drop down for the different languages that we can run natively inside of it. So everything I'm going to show tonight is in Python. Hopefully it's readable and makes some amount of sense. Again, this tool is free, and it works very similar to what was described earlier. If you need to add libraries, you can just use an exclamation, pip install whatever tool or libraries or whatever it is that you need. You're not root on this one. We're not quite that good yet. Okay, so let's just run through the code. Okay, first thing I do is I can show it if anybody's interested, but I built a simple little Python script that went out and scraped all the data off of the pro sports site. It pulls it back into JSON, and I just created a big fat JSON file that represents all the NFL data for all the regular season games between 1990 and 2015. So I get to play with about 25 years worth of games. I dump that into JSON, and then what you can do with this is you just drag the JSON file up onto the page, it uploads it, and then I can just go to resources, football scores, JSON to the file path that I sent, or that I put up there. So I just create a pointer at the file, create a Spark data frame around that JSON data set, and away we go. And so this is the raw kind of output of the first 2 rows of that data set.
What you use to scrape it?
Python and libxml. Sorry, did everybody catch the question? Was what did I use to scrape it? Just Python. Okay, so we've got 6,667 games to play with. This is a nice output. One thing that Spark does really nicely is when it sucks in JSON, it's really nice and easy to spit out the schema, so you can get a nice layout and see what it actually looks like. I of course built the schema, so I know exactly what it looks like, but it is nice. It does show like that for example, the stadium here is under the box score, which is nice, just easy to reference and understand where to go to get that specific piece. And the first thing I need to do, like I said before, is one of the first challenges was my data was very flat. And so I want to flip it, normalize it, make it very narrow. I want a row for every single team that plays. So that when I go and run the correlation, I can just simply say group it by team and we can go. So another nice thing with Spark in general, so who's using Spark right now internally? A handful, okay. So my favorite part about Spark, personally, isn't performance. Like that's all the hype, everybody reads about it, and it performs really great, and it runs in memory, and it scales really well, and all that stuff is awesome. I like Spark because I can attack it in like 80 different ways. I can get one piece of code in Python, I can do another aspect of it in R, I can do another aspect of it in SQL, and the ability to mix and match and kind of marry these different approaches, from my perspective, makes it way easier to tackle these types of problems. So like this one, instead of trying to figure out the perfect way to pivot using some nuanced Spark, Python rigmarole, I just wrote a select statement that just does a union on all the wins, all the losses, and just normalizes the data into one simple set. So, really dead simple and a little bit of brute force, but the tool is there and it's pretty easy to do. Okay. So out of that, now I have this nice normalized set. I have, you can kind of get a look at all of it across. The only thing that I did is I added a new column for 1, and I just do simply a 0 if I lost, and 1 if they won. Okay. So a couple of quick graphs that I was able to build. So there's actually 2 notebooks available up on the data science workbench. One of them is this Jupyter-based one. The other one is Zeppelin, which does, in my opinion, a little bit nicer job on visualization. So for this one, I would just use the simple visualization with Datalab. And that's what you'll see here. I'll flip over to the other one and give you a sense of what it looks like with some kind of more interactive. And I have a little dashboard, and we can see what those look like as well. But dead simple, first thing I'm going to do is I just want to go through and see, with my 25 years worth of data, who is the winning most team that exists, which I didn't know any of this when I started with this, and I was kind of surprised. So I go left to right, the most winningest team in history of my 25 years was the Patriots, which I thought was kind of sucks, but it was, it is what it is. I was glad to see that we're in the left half of the 50%, so that made me feel a little bit better about just life in general. So that was good, that was kind of interesting. So then the next thing I do is I go through and I pull just a simple, okay, how many wins divided by how many years that the teams actually existed. So you have interesting things like the LA Rams weren't really around that long. and they also weren't very good. If you look at like their win ratio for the time that they did exist, or at least within, I might have caught part of the season or something. But again, Patriots still pretty dominant. We fared out fairly well in here, somewhere in this range. But a good sense to kind of see where these teams stack up year over year for the last 25 years. Okay, so starting to get closer to the weather stuff. Now I'm going to go in and I just do a very simple count, and I'm just trying to figure out of all the games that I have, how many of them are outdoor and how many are indoor. I also thought this was interesting. So the big, I don't know what color that is, not pretty green. That's representing all the outdoor games. So it's like 75.69% of all NFL games in the last 25 years have been played outdoors. That actually does not take into account domes with retractable roofs, or at least according to that website with that data set that I played with. So I thought it was fairly interesting, right? So we have a good subset of data that we're actually going to be able to play with. And then this is a good like numerical look at, okay, just back of the napkin, indoor games versus outdoor games. Do they have less yards? Do they have less points scored? Do they, overall, does the inside versus outside impact whether or not, how a game's output goes? And you can certainly see it. We have enough data sets here where it's pretty significant that, a point or two less, or I don't know what it turns out to be, say 25 yards-ish less for the winner or the loser, given indoor or outdoors. It certainly exists. And here's kind of another way to look at it. So you can see kind of a nice charted perspective that certainly a dome is kind of the furthest point out here versus outdoors is quite a bit less. Funny enough, retractable roofs, people do not score well or get a lot of yards, which is beyond my comprehension. Sorry, put the wrong button. And then points by stadium type. So same basic principle. Okay, team analysis. Which teams have the highest win ratio outdoors? Okay, so now let's just look at the outdoor games. Who's the most winningest outdoors? So it's interesting, right? Because earlier we had the Patriots were the #1 most winningest team as a ratio of wins to losses, or actually, I take that back, average wins per year. But if you look at wins to losses outside, the Packers actually do, and the Steelers, and then the Patriots. So it's kind of an interesting difference in varying overall how they play. And it also, again, kind of common sense should tell us, I would think the Packers play well outside in the freezing cold and snow, right? So it just shouldn't impact them as much as everybody else. Okay, so now we go through, I loaded some data from Wikipedia. Again, it's kind of a shortcut. I have another Python script that I wrote just to scrape the data and dump it into a CSV file, and then drag the CSV file into here. All I'm really pulling through at this point is I pull through the location, the stadium, and the team that's associated with that stadium. And then I got kind of worried. So when I married up the Wikipedia data and all the stadium data, I got about 50% matches. So not high enough, not as much as I wanted to, right? So I had to go in and look and figure out what was missing. And obviously over the last 25 years, stadium names have changed. I only have the stadiums that are currently exist for each team. And things like Gillette Stadium wasn't originally called Gillette Stadium. So what I did is I just went through and I figured out which ones were missing. And I actually ran it against the top 10. And just for those 10, I went in and hacked together a fix. So I found this to be fairly useful exercise in the ability just to take a simple list and marry it up to an RDD within Spark and kind of marry it both into a new RDD. Where what I did is I just created a simple list or dictionary that contains all my values, iterate through it and add it to the list, and then I iterate through the RDD and add it to the list. So this wouldn't work for a big volume issue, but it definitely worked really well for kind of a small metadata type markup. So it works. And it's a little hacky, which I like. And then so now I have 42 stadiums instead of 32 because I added my 10 new stadiums that I hacked in there. And now I get a slightly better match, 72-ish%, which I'll live with. Good enough for tonight, I hope. Okay, so now we go to weather underground data. Found this API to be immensely easy to use. It's basically just a URI with the state and the date within the URI itself. So there's no fancy notes with REST or anything like that that I fool around with. And being able to marry it up and just build the string for all of the URIs is dead simple. So that's what I did. So what we do is the first thing is I just basically go in and I knew I had some issues, like for example I need leading 0, so I create a little function to do that for me. And then I just have this dead simple function that basically goes and builds my entire URI for every game that exists. And then again, back to why I like Spark, I'm able to just register that as a SQL function. And by registering it as a SQL function, now all I have to do is run a select against the entire scores data set that I have, and it just marries it up for me. Oh, I had to hide my API key from all of them. So, okay. So all at the end of this, basically what I come up to is, if you look at this set, what I have is all that same data they showed you before with just a simple weather API call, URI, excuse me, that contains all that information. Then I create another function, and this function takes the input of a URI, and it returns a dictionary that contains all of the value associated with that subset of my daily summary, right? So I just quickly jam through to the fact that if history daily summary exists, just give me the dictionary in the back that exists within that JSON blob, or return nothing. But I have to be careful because I want to actually return an empty dictionary, because if I return a none type, it blows up and it takes you about an hour to debug and figure out that that's what you just did yourself. So that was a good use of my time. That is something to be super aware of, is that when you do run maps or you're kind of playing around with Spark. So Spark in general works with lazy evaluation, which means that I could have done a million different things and gotten 85 pass down this and actually not moved any data or had the system process anything yet, because I'm going to ask a question. So as soon as I actually go in and do some real processing, it's going to go back to the first one and cascade all the way through all of that code and get to the point where it's going to answer me. It makes it super hard to debug. So a lot of times, like what I end up doing is just go ahead and pull the count or pull some values out of it just to get it to process to make sure that I didn't break something, right? In the future, it's nice when you have like to strip out all those counts, kind of for future analysis. But as you're going through and building these cascading RDBs, I'm on my 15th iteration of this data set right now with all these different perspectives and adding URIs and doing all this stuff. So certainly a lesson learned on this one, which is, don't throw nut types into your RDBs. It's not fun. Okay, so test the function. At this point, all I'm doing is just going through and pulling 2 days worth of data. I actually tested it both ways. I tested with a good URI and a bad URI just to make sure that I get a value back in case we have a mistake, which we did. Okay, so now I just go through and I do a fairly simple map. I didn't do this one in SQL. I used the native Python, and we go through and here's my get weather function that calls that weather URI to get my data set back, and then I just take 2 records back and split them so that they're mildly easy to read. Because raw JSON is always super easy to read. Okay. And then to make it much easier to use, I go in and I define each of those columns So I'm actually naming them. So I'm just saying, this is my data set, or this is what a year is, name the team, etc. Okay, so we're almost to the correlation part. So a couple of really quick things I needed to do. Again, that data set that got returned, I don't know, I'm sure it's impossible to read, but buried in all this JSON big blob here is a dictionary that contains all my weather data. Yep.
So how do you consider the weather? So it's like average on a particular day, we take an average.
So you take the so the weather for a particular, okay.
So on the game, on the day with the game has been.
Yes, yes. So if I understand the question correctly, it's like, how do I marry a day to the day that the game was actually played? Like okay, so I don't go to the hour. I was too lazy for that. I simply take the daily summary. So what gets returned back from the weather API, the weather underground API, is an hour by hour for 24 hours measurements of everything that I'm going to show you here in a second, as well as a daily summary of all of those metrics as well. And it's things like you would expect with weather, like pressure and humidity and temperature, min-max temperature, like all that stuff exists within those blobs. It exists on an hour basis, it exists in a summary. I just took the summary. Just assuming that for all intents and purposes, it was either cold and rainy or it wasn't. So, certainly would be something we could incorporate a bit deeper. If, my job depended on this, if I was actually going to play some bets, right? Maybe. But it didn't get quite that good at this. Okay, so you good? Okay. Just a couple of really quick functions. This one just goes through and it just checks to see if there's a value in the dictionary. If it is, returns it. And the other one goes through and it converts everything so far got interpreted as strings. I need it to be floats if I want to do any actual math on it, right? So a couple of helper functions there. Now I can create a table that's built off of all of this data. I check the dictionary for the value, I return the float, and I get this nice clean table that contains, at least for these specific metrics, the mean temp, the precipitation, and the wind speed, pressure and humidity, and then all that other stuff that was in there, the team, the yards, the stadium, location, points, whether or not they won. Okay, so then first thing I did is I go through and I look at the average of the mean temperature, wind speed, pressure, humidity, precipitation, all that stuff. What I really want is I just want to compare the wind speed and the temperature on average for each of the 32 teams. And I just threw it into a quick scatter graph to see where does everybody fit kind of in this spectrum. And it was pretty interesting. So like there's these outliers, like the Chicago Bears. Let's see. So the Chicago Bears are this great big outlier on the top because it's windy and it's cold in Chicago. So again, a little bit of common sense here, but kind of interesting that the majority of their games, and this is all the games they've played, right? Away or home, are cold and windy on average. They play 9 miles an hour wind, which I thought was super interesting. And the most kind of fair season team that exists is Tampa Bay. And funny enough, I don't remember if I included this. I didn't include this, but I have another version of this where I went and compared Tampa Bay to Chicago. Tampa Bay does not play well in Chicago. That was the one real crystal clear thing that came out of this. Was you do not want to bet on Tampa Bay when they go to Chicago, ever, ever. It's like 14-1 or something like that. It's just a ridiculous stat. But anyways, this is what's that?
I don't think you want to bet on Tampa Bay.
Okay, so that that's really funny because I was all excited and I told my wife this and look how crystal clear this is. She's like, yeah, duh. Tampa Bay sucks. Well, even yes, even she knows that it's not good. So So anyways, kind of interesting, you know, you see these big blobs of all the teams, and just a nice, I thought it was a nice way to visualize and kind of get some sense from a wind and temperature perspective of how teams play out. And, you know, also somewhat interesting is that, you know, things that we would expect, like earlier we were showing how well Green Bay does outside, right? Look at them on the top left of this chart. They play in the worst weather. So any fairer weather that they typically play in, I would expect them to not be as impacted by it. So simple. Okay, so let's go slightly deeper as opposed to just some visualizations. I didn't do anything tremendously more complicated than just doing a simple correlation with Pearson. So all I'm doing is I just take two vectors and I say, are they correlated? That simple. And so the first thing I did is I just took all my data and put it into a perspective that made it easy to see whether or not I'm building my vectors correctly. So this is what the rows of data look like. Then when I pivot them and I turn them into vectors, this is what the vectors look like. And I'm just eyeballing it to make sure I have the right order and it's not, I'm not doing something wonky and all that. But then I can take those two vectors and I can run Pearson against it using the Spark MLlib, and which is kind of fun. It was literally one line of code to write that, and boom, no correlation. Which was frustrating, but it is what it is. So this is, if I remember right, no teams, no nothing. So this is kind of across the entire set. So what seems like it would make a lot more sense, right, is if we didn't look at all of our data and figure out whether or not it's correlated between the weather, the wins, and the losses. I have a couple of issues, right? One is that for every game I've got two measures, which is going to make it kind of wonky to begin with. The other thing is what I really care about is for a given team to have a correlation between the weather or some aspect of the weather and whether or not they've won or lost or some aspect of the game. So we'll start with the Bears. So I just filter down my data set down to the Bears, create my same two vectors, run a correlation against that. Not tremendously better, but a little bit, and a little bit encouraging. Okay, so now I'm going to take all that stuff that I've done, building the vectors, filtering out the teams, all that fun stuff, and I'm basically going to make it repeatable, and I'm going to create this function that will go through and let me throw in a game metric, so it can be for, what I say, yards, turnovers, points for, points against, and whether or not they won. So those are kind of my key game metrics. And then on the flip side, I have all these weather metrics that I can throw against it. So I can throw the mean temperature, I can throw the snow, yes or no, rain, yes or no, number of inches of precipitation, etc. So I can throw those against it. So simple example is points with max temperature doesn't correlate. For the Bears, sorry, for the Chicago Bears. Okay, so now do the same thing with rain. Rain and yards for each team. Okay, so now that I have this function working, what I'm going to do is I'm just going to go through, I'm going to loop through every single team, run that correlation for a given set of metrics. In this case, precipitation in yards, and just have it return back a nice simple data frame that I can visualize and go from there. First, I actually dump it into a table called pi and then do a select star from pi just to get the output. And be a little bit better visualization. And what it shows is, for example, the Texans and the Dolphins tend to not do very well in the rain, in theory. That's super statistically significant, but enough to say that there's certainly outliers, and we wouldn't want to bet on them in the rain. Or as my son told me last night, apparently the Dolphins don't like the water, which he thought was really ironic. So I promised I'd share that joke today. I'm glad you guys laughed, because he would have been brokenhearted if you didn't. And then you see kind of these opposite correlations where there's actually, we have the Cardinals and the Oakland Raiders, funny enough, actually played better in the rain. So why those are outliers? Again, not hugely significant, but enough to be kind of outliers of the rest of the set. And then one more where we can compare the temperature and winds. And I thought this one was interesting, or I have problems with my data quality, which is, could be either. But here's one where the Patriots tend to do better when the weather's cold, which I thought was mildly interesting. And then you see kind of some more outliers out where the Saints don't like cold weather, or they will play better in warmer weather is probably a better way to say that. So the Cowboys and the Packers again, which marries up to exactly what we saw before, right? Is that the Packers and the Patriots are on the far left of our scatter chart, where they tend to play in really crappy weather with a lot of wind, and they tend to do better there.
So you proved Brady was playing balls for the last 20 years.
Yeah, exactly. So yeah, we need a pre-post deflate gate chart there. Right. So that's it for the simple correlation. But I can show if it works. Yeah. Yeah.
Plotly chart library.
Plotly. Oh, the scatter graph. Yeah. So I found this today. And I actually found this about an hour before I came down here and went ahead and risked throwing it in here. But I did find that Plotly. So it's just a simple API that you can call, and it's much. The problem that I was having is Datalab. The scatter charts are a pain in the butt to work with, and they don't have. It's hard to get the visual, the color, and they just return these just static images, right? And so this chart itself was next to impossible to read if I couldn't hover over where the different outliers were. So it's definitely a pretty slick little tool. It didn't look like it was terribly expensive. This is just working for free. I don't know how I got that to happen, but it did. So
If you ran linear regression on that, you'd have a pretty nice line.
on the other one, yeah.
No, I mean the one you just had there.
This,
Yeah,
yeah.
you pretty much have a pretty much negative slope.
Sorry, the season. Braden, are you about to wrap up, or?
Yeah, I'm good.
Okay. So let's make this a bit more orderly because I love order. We'll start with you. Who else has questions? 1, 2. Anyone else? Anyone? I have a question too. So on 3, you were there next to the handy camera. All right. I'm going to come to you so that everyone can hear your question. Is that okay? All right.
So based on the data, are the results that the teams play better in weather that's similar to their own weather in their home turf?
It appears that way, yeah, for sure. And a little bit of this might just be the fact that a lot of the statistics for the games that they play in general are more prone to their own turf, right? So at least 50% of the games that they're playing, for like Tampa Bay example, 50% of the games they play are in Tampa Bay, where it's warm and not very windy apparently, which I didn't know that.
Most important question is around how are the Hawks going to do next weekend?
Yeah, so,
Predicted to be one of the coldest NFL games on record.
It's funny. So I actually, and of course it blew up on me right before I got into it. I actually built a quick little dashboard to kind of show how, just as another type of notebook that you can use to play with this data, as the Zeppelin one. And I had these nice drop downs up here, and I had this all pre-canned. It turns out that we tend to dominate the Vikings pretty well in general, and most of the correlation that I saw was that the Seahawks in general are not as impacted by weather as most teams. Right. So I think we're
Bet a couple $100.
Yeah, I think here you go. You're a couple $100, right?
My question.
Yeah.
So, first, this is a lot of fun. I'm really enjoying what I'm hearing. And I love when a lot of data scientists come in and do topics that are relevant to even like either a novice or a completely, data science agnostic audience as well. Myself, I'm going to include myself in that. I think my first question is, it's very easy, therefore, to have a lot of preconceptions about what this should turn out to be, almost like causal logics. I'd like for you to share a little bit about what you expected to happen.
Sure.
And what was surprising. Maybe there were certain things that didn't correlate as well. I think one of the big notable things is that when it comes to a lot of teams that we kind of presume like New England and Green Bay being adapted to the cold because they trained there and they played mostly there. There's a lot of like variables that we don't really have to think too deeply about as to why that's happening. But I'd love your insight on the things that maybe certainly require this kind of investigation.
Yeah, no, for sure. So probably the first one that really, I shouldn't say shocked me, but I think I was a little over my skis on is when I seen the topic that I thought I could predict wins and losses. And I don't think it was nearly as easy to go in and literally tell win and lose. That correlation was pretty rough. Going in and figuring out yards scored versus precipitation or wind and how it impacts certain aspects of the game, like, and again, maybe common sense, but I think you could get into building a predictive model around if the temperature is this and the precipitation is this and the wind is this game is probably not going to score this high and it's probably not going to have this many yards. Some of it might be common sense, but it might be great for your fantasy pick of, this guy over this guy to literally say like, yeah, you know what, they're not throwing the ball a lot, or historically the Packers haven't thrown the ball a lot when X, right? So that was a little bit surprising to me. Some of the simple stuff was actually interesting to me. Dead simple, like I didn't realize that many games in the NFL were played outside. I didn't realize that I don't want to live in Green Bay ever. Badly, right? In Tampa apparently is where I'm going to retire, so lots of good stuff out of that.
I was just informed by your colleague that they just fired the coach of Tampa Bay. So I don't know if
Maybe I should go show them this.
Maybe his job can still be salvaged by your data.
I can run the team of data. Yeah, exactly.
I don't know if I missed it. Did you say if you were sharing your notebook?
Yeah, I'm happy to share the notebook. That was one other thing that I should have shown earlier. It's very similar. So you get this little toolbar with this tool. I'm going to share it right now, and it's in all you can link. There's this really neat way where you can go in and you can just click on this and just create a gist for it, and then you guys can all grab it. Really handy, very similar to what we saw earlier. This is also where I can see all of my different data sets. For example, somewhere in here I have some, I don't know, there's data in there somewhere. Yeah, more than happy to share.
Like 3 more questions. 1, 2, and the last one is going to be our last one. 3? Okay.
Do you account for the fact that teams may have moved from outside into domes, and so you might not have a balanced data set? So like if in the 90s they were really good, independent of the fact that they played more of their games outside, and then they moved into a dome and they were really bad, just because like someone retired or something?
Yeah, that's a good question. So I didn't account for it. I took it kind of at face value that really just where the game was played at a given point in time. I don't know, that's a good one. That's an interesting one. And I don't know off the top of my head the team's home fields well enough to know which teams would have moved. You know what I mean? Well, Vikings. Yeah, we talked about Vikings earlier, that's a good one. But beyond the Vikings, I don't know if I'd have enough data to be able to kind of pop back into it and say, what's the trend line look like for those? But that's a good one, it's interesting.
Did the NFL data site that you pulled your data from have point spreads associated with the games? And did you do any analysis against whether or not they covered the spread or not, and if certain teams had a tendency to be affected more by weather based off of spreads?
I didn't. Yeah, and actually, I would almost think, honestly, one of the most interesting things from a spread perspective, now that I have all this data and I can get to that spread info, I think it would be actually more interesting just to see how close to those spreads things are. There's lots of, conspiracy around whether or not people are getting pulled or the way that the games get played in the fourth quarter based on the spreads, right? So I think it'd be kind of fun to go and just see if you can be like, that looks fishy. I didn't necessarily do that with the data I played with. I really only went to the depth in the box score of just pulling the stadium. But there is all of that information there. So maybe I'll think about playing with pulling some of that. It'd be kind of interesting. So, somebody else is picking it, right? Somebody else is doing all this work to get to that spread.
All right, last question.
So when you were looking at the data that was in the tabular format, what was your thought process that then you took that data and put it into a different sort of analytic framework to make Spark work on it better?
Oh, that's a good question. So probably because I have a pretty long history in SQL, like I just have I probably learned I was probably strongest on SQL first and any other language second. And so you'll see, like, when I was walking through all this, I fall back on that crutch all the time. And for all kinds of different reasons, whether there's just an easier way to pull the visualization or express data, right? So it's a little bit of that mindset of the right way to organize it would have been, in my mind, if I was building a data warehouse, would have been to completely normalize the data into that single set. So that's a little bit of why I did it, but you can see that all the queries that happen after I do that pivot become immensely easier. Like just taking wins over losses was that much easier because it was all in that single column. All I have to do is group by the team. And I don't have to write case statement, I go and pull it out, and do all those things. So in general, I mean, just with the nature of almost all of this data stuff, the more normalized it is, the easier it is to work with, from my perspective. Yeah, one more?
I was just wondering how long it took you to put this all together, whether we could come to data fantasy football.
So as a work in motion, I don't know. I honestly don't know. Probably a week-ish, roughly. I started working on this idea right before Christmas, and I've been playing with it whenever I get a free minute since kind of through our Christmas break, if you will. And it's one of the things that certainly started me, so I probably put a few more hours into it than it was necessary, but I had a lot of fun with it. And to your point, I'm a huge fantasy guy, so I'm literally trying to figure out how do I incorporate this down to a player level so that I can go through and actually start to figure out. I mean, you should literally be able to get to a really easy and simple metric that says, if I know the weather, which I can predict the weather, and that was a little bit of why I was trying to show this one earlier, is this is a prediction between the Packers and the Redskins, and I know it's super hard to see if this is what the weather's going to be like on that day, and then I can just bump it up against these charts. So maybe it's not super scientific, but I can pretty much back into like, I think Green Bay might have the Redskins, like historically at least, right, or whatever I want to go with. If I get this down to a player, and I can pick two players and be like, they're on my, which one do I bench, which one do I play? That's what I'm after. So it'd be kind of fun.
All right, everyone, please give it up for Braden Callahan. Did y'all enjoy that talk? Is that not like a whole lot of fun one can have with data science around here? And if you like Braden, I think I do, he'll be back in 3 weeks to do yet another talk right here at Galvanize as well. So please show up to that. We also have 2 other talks this month alone with Seattle Data Science. Another one we're doing with Seattle Apache Spark that's happening next week if you're really into Spark, and we're really seemingly into Spark this month anyway, so please come to our events. Go check us out on our Meetup group, Seattle Data Science. We're very open and loving and all that stuff too. Lastly, we are good. I think it's, the time's gone. I think we're at 7:40? We are scheduled to be here until 9, but let's maybe make it a little bit safer so everyone goes home nice and safe and sound, and let y'all mingle till 8:15. So please eat all our food. We have way more food than that. Take home food if you like as well. Hang out here, chat with Braden, chat with me about Galvanize, chat with each other. Thank you all for coming. Thank you so much.